Using algebra tiles, you can see that we've taken our 1x squared piece, our 1, 2, 3, 4 x pieces, and then our 1, 2, 3, 4 little 1 pieces, and we've arranged them into a square. Now, the length of this side is going to be x plus 2. And because it's a square, we also have x plus 2 as the height or the width. So we can model this algebraically as saying that this particular square has an area of x plus 2 squared. Now, if we want to expand that, we know x plus 2 squared is just the base times itself 2 times. And when we go to square a binomial, we know that we're going to FOIL it out. So we're going to multiply our first terms, our outside terms, our inside terms, and our last terms, and then combine our like terms to end up with this expression. Anytime we multiply two binomials together, we FOIL, but if we have a binomial squared, because it's the same thing in both brackets, the quick way of doing this, remember, is we're going to square the first term because we're just multiplying this by itself. We're going to double the product. So because our outside product and the inside product will always be the same, we're basically just going to multiply this together to get the product. 2 times x is 2x. Double it because we're going to add to that another one, and that will give us the 4x. And then we're going to square the last term because, again, it's always going to be that number times itself. You may also recall that this is what we call a perfect square trinomial. So in order to factor it, which is what we have up here, remember we square root the first term to get that value, we square root the last term to get that value, and the sign is the sign that's going to be right here. Now if we take the total of all pieces represented here, and if I put, let's say, a y equals on this, I now have a function written in standard form. If I put a y equals up here, I have a function written in vertex form. So our goal for today is we're going to take a look at how can we take something in standard form and get it into vertex form where we're going to have that squared binomial. We're going to model this using algebra tiles to see what's happening visually. So the first thing we need to do is gather up our pieces. So we have 1x squared, 4 negative x's, and 5 of the positive ones. Now we're going to use the colored tiles as positive, and we're going to use the white or the blank tiles as the negatives. So once we have the pieces together, our goal is to try to arrange them in a square. So we're going to start by putting down our squared piece. We're going to lay 1 here, 1 here, 1 here, 1 here, and then we're going to take our little ones and fill in the gap right here. And you can see that we have 1 piece left over. So this length here, we have an x, and then minus 2. On the other side, because it's a square, we also have the x, and then minus 2 there. So we can see that x minus 2 squared gives us the square here, and then plus 1, we have 1 little piece left over. So now if we want to check to see if this vertex form correctly represents the standard form, let's try this out. So we're going to square the first term, and we're going to get x squared. We're going to double the product, so negative 2x, multiply those two terms together, times 2 gives us that negative 4x. Square the last term, negative 2 squared is positive 4, plus 1 gives us positive 5. Also notice we're taking our x pieces and we're dividing them in half. Half of them go on this side, half of them go on this side. Half of those x's, so in this case negative 2 squared, tells us how many of those ones that we need to complete the square, and then we may have some pieces left over. Now in this particular one, we have 2x squared, so we're actually going to make 2 different squares. We're going to begin by taking our 12x pieces and dividing them into 2 groups. So we're going to have 6 in the first square, and we're going to have 6 in the second square, and then we're going to go 1, 1, 1, 1, 1, 1, and then fill in this gap with our little 1 pieces. So you can see that we've got 9 tiles here, but we only have 15 ones. So I'm going to have 10, 11, 12, 13, 14, 15, but you can see that we still need 3 more tiles that we don't have in order to actually make this second figure into a square. So if I'm going to actually complete this square, I need to fill in 3 extra pieces that I don't technically have, and I can do that as long as I also add 3 negatives, because remember, every time we have a positive tile and a negative tile, those are going to zero out. So these pieces here actually all zero out, so I haven't changed the question from my original 15 tiles. So you can see that we've created 2 identical squares. Each has a length of x plus 3, and we also have these negative 3 extra pieces that we had to add on there. This in standard form is equivalent to this in vertex form, and we can quickly FOIL this out. X squared times 2 gives us the 2x squared. Double the product. 3 times x is 3x, times 2 is 6x, and then multiply by that 2, that gives us our 12x. Square the last term. 3 squared is 9, 9 times 2 is 18, 18 minus 3 is 15. So visually, we can see how we can take something in standard form and convert it into vertex form by a process called completing the square. The process of completing the square is the second way that we can take an equation in standard form and convert it into vertex form. The first method being that x equals negative b over 2a. All right, so if we start with something in vertex form and expand it, we're going to begin by squaring this binomial. So we're going to square the first term, take the product, double it, square the last term. We're then going to distribute in that 3, combine our like terms together, and we're going to have standard form. All right, so let's now take that same standard form and try to revert what we just did. So we know that in vertex form and in standard form, our a value is the same. So I'm going to begin with my a value, and then our goal is to get this binomial squared. In order to do so, I have to have a perfect square trinomial that I can then factor. So I'm going to take these negative 30x's, I'm going to divide them among the 3 squares. So each square is going to get negative 10x's. Half of them are going to go on the length, half of them are going to go on the width. So we're going to have 5 of those x's here, 5 of those x's here. That's going to give me x minus 5. So now let's see what we have. So I square the first term and then multiply by 3. That gets me back to 3x squared. Double the product, so negative 5x times 2 gives me negative 10x, times 3 gives us that negative 30x, and then in terms of the constant term, negative 5 squared is 25, times 3 is 75. So right now we have 75 little ones, 75 constants. We need a 71. 75 minus 4 will give me 71, and that's a really quick way that we can complete the square. In time, you're going to be able to do something like this very quickly, where you go from standard form right to vertex form in one step. But in the beginning, let's break this process down a little bit more so we can see what's happening. And then the other thing is sometimes you're not going to necessarily have whole numbers. And so depending on what values you're given, it might be a little bit easier to go step by step through a process. So the first thing we're going to do is factor out the a value from the first 2 terms. So that would be the x squared term and the x term. What we're doing basically is we're dividing up 3 different squares. We're taking those negative 30x's and we're dividing them amongst the 3 squares. So each square is going to end up with 10 of the negative x values. When we set up the bracket, we're going to leave a space at the end. You'll see why in a second. And then in addition to our x squared and x terms, we also have these 71 1 terms, which we're going to just leave at the end there. Each square is going to get negative 10x's. Half of them are going to go along the length. The other half are going to go along the width. So we're going to take the x term. We're going to divide it in half to figure out how many are going on the length, how many are going on the width. And then we're going to square it to figure out how many of those tiles are going to go in here in order to complete the square. So we can see 5 squared is going to give us 25 tiles per square. We're going to add that value to our bracket. So we're going to put in here this plus 25. And I now have a perfect square trinomial. So that was my goal in order to get my binomial squared. But don't forget, we still have these 71 ones off to the side here. I can't just add something to an equation. I've now changed it unless I remove that same amount. So I'm going to add the 25, knowing that's what I need to complete each square, and I'm automatically going to subtract those 25 to zero them out. So we still have our 71 ones over to the side here. We can now factor this perfect square trinomial. So remember, we're square rooting the first term, we're square rooting the last term, and the sign is the sign that goes here. So if you take a look at your square here, you can see that we have each side length as x minus 5, but we still have this negative 25. So what we're going to do is we're going to multiply 3 times negative 25, because remember we added 3 sets of 25, we subtracted 3 sets of 25. That's going to give us negative 75, and then we're going to combine it with its like term. So we're going to add those two together, which gives us a value of negative 4. That's the Q value in vertex form. Now, remember, to begin with, we had 71 of the little one tiles. We put 25 here to get 50, and then we didn't have enough to get to 75 here. We only had 71. So what we had to do was add in 4, and then automatically we had to subtract 4. These are going to zero out, allowing us to get the appropriate amount. So we subtract those 4 extras that we had to put in there in order to complete the square. Okay, so let's practice this. Step number 1, we're going to factor out the a value from the first 2 terms. So in this case, a is 1. If I divide 1 out of those 2 terms, I'm still going to end up with 1x squared and negative 22x. I'm going to leave this space at the end of the bracket. That's what's going to go in there to complete the square. And then we're going to have this plus 13. I'm now picturing my square. I've got negative 22x's. Half of them are going on the length, half of them are going on the width. So I'm going to take that value, divide it in half to get negative 11, and then I'm going to square it to figure out how many of those little ones have to go into the corner of that square. So that's going to be 121. We're going to add that 121 in order to complete the square, and right away we're going to subtract that 121 in order to keep it balanced. So second step, we're going to half the second term and square it. We're going to add those in, and then right away we're going to subtract them. Now have our perfect square trinomial that we can factor. So square root the first term to get x, square root to get 11, and remember the sign is the sign that we're going to have on that value of x. And then right now we have a 1 as a coefficient, but don't forget we have 1 times negative 21, so we still have those negative 121s that we added. We're going to combine those with the 13 that we have on the outside. So when we put those 2 terms together, negative 121 plus 13 gives us that negative 108. So our function in vertex form is going to be y equals, we've got x minus 11 squared, and then minus 108. And then we're going to check this. So square the first term, we get back to x squared. Double the product, negative 11x times 2 is that negative 22x, and then square the last term. Negative 11 squared is positive 121 minus 108. Check to make sure that we do in fact get 13. And then as we get more proficient with this, what we're going to do is we're going to say, okay, a value is the same from standard to vertex. So I know my a value is going to be 1. I know I'm going to have a binomial squared. So I'm going to square root this first term, and I'm going to get an x. I'm going to take my negative 22x's, and I know I need to divide them in half. So I'm going to have negative 11. I know that I now have x squared to get my first term. Negative 11 times x, double that, gives us our x term. In terms of the ones, we have negative 11 squared is 121. I need 13. So to get from 121 down to 13, I need to subtract 108. In our next one, we're going to have an a value of negative 2. So I'm going to divide that out of the first 2 terms, leaving me with just an x squared. And then 5 divided by negative 2 is going to leave me with negative 5 halves. Now we need to take half of those x's, and then we're going to square them to determine how many ones need to go in there to complete the square. So when we go to do this piece, it might just be easier instead of dividing by 2. We know that's the same as multiplying by 1/2. So I'm going to multiply negative 5 times 1 is negative 5. 2 times 2 is going to give me that 4. And then we're going to go ahead and square that whole piece there. Negative 5 squared is positive 25. 4 squared is 16. So we end up with 25 over 16. We're going to add that, and then right away we're going to subtract that. And this is going to give us our perfect square trinomial. So now we're going to leave our a value as negative 2, square root the first term. We're going to have minus because of that minus sign here. And then I'm going to square root this term. So square root of 25 is 5. The square root of 16 is 4. So there is my binomial squared. And then we still have this negative 2 times negative 25 over 16. So we're going to multiply a negative times a negative is a positive. 2 times 25 is 50, and 1 times 16 is 16, because remember, we have a denominator of 1 down here. And then we're going to add that to our 8, and I'm going to write this over 1 just because we're going to need a common denominator. And then at this point, I would probably divide 50 over 16, the numerator and denominator, by 2 to reduce it. So my numbers are a little bit smaller. I can see that my lowest common denominator is going to be an 8. So I'm going to multiply each of those by 8 to keep it equivalent. So 8 times 8 will give me 64. 64 plus 25 will give me 89, and we're going to keep the denominator the same. So we're going to end up with -2. Our vertex is going to be at 5/4 and 89/8. And then again, quickly, FOIL this out, distribute in the -2, combine your like terms to make sure that you do in fact have the same standard form. And one more just for good measure. So I'm going to begin by factoring out my a value from the first two terms. Now we have 1/2. If I go -13 divided by 1/2, that's the same as -13 times 2. So we're going to end up with -26x terms. I'm going to leave my -15 over here outside of the bracket, and I am going to write this as a fraction just because it makes some of the mental math a little bit easier. Okay, so now to figure out what we need to complete the square, we're going to take those -26x's and we are going to divide them in half, and we are going to square this. So -26 divided by 2 gives me -13. -13 squared will become +169. So we're going to go in here and we're going to add 169 to get our perfect square trinomial, and right away we're going to subtract that in order to zero it out. So this is now factorable. We're going to have y equals, so 1/2, square root the first term. We're going to have a negative, and the square root of 169 is that 13 squared. And then when we go to do the last piece, we're going to have 1/2 times -169, which I'm just going to leave as -169 halves minus 15. And I am going to write in the denominator here because we know we're going to have to subtract those two. Okay, so we've got y equals, we're going to have 1/2 x minus 13 squared. I need a common denominator. I can see my lowest common denominator is going to be a 2. So I'm going to multiply both of those by 2. And then I know that my denominator is going to stay the same. So that's going to mean my denominator is 2. This is going to become -15 times 2 is -30. -169 minus another 30 is going to give us -199 halves, which remember is going to give us the coordinates of the vertex for that parabola. In the previous lesson, we were able to convert a function in standard form into vertex form by finding the x-coordinate of the vertex using that -b/2a formula. Well, it comes from the process of completing the square. We can begin by factoring an a out of the first two terms. So we're going to go b divided by a to get that value. And then we're going to take half of this and we're going to square it. So I'm going to go over here and just multiply b times 1 is b divided by 2a squared. And when we do that, we're going to end up just with b squared over 4a squared. So I'm going to add and subtract that to my brackets. That's going to give me the perfect square trinomial that allows me to factor. So I'm going to square root this term. We're going to have a plus. And when I square root this term, we're going to have b over 2a. So we're going to end up with that. That is where this -b/2a comes from, because remember, it's always the opposite sign when we're pulling out the vertex. Now, in terms of simplifying this next piece here, we're going to go a times -b squared over 4a squared. And so that's going to give us that -ab squared over 4a squared. One of those a's will divide out with one of those a's in the denominator. So let's go ahead and cross those out there. And then I'm going to combine these two. I need a denominator that's common in order to do so. Okay, so we go ahead and do that. We're going to simplify this term down to the b squared over 4a. And then I can see that my lowest common denominator needs to be that 4a. So I'm going to multiply 4a times c. And then these will not be like terms in the numerator. So I'm going to just leave them as two separate pieces. So we're going to have a b squared plus 4ac over 4a. This, remember, is the y-coordinate of the vertex. So oftentimes we just substitute back in because it's simpler, but you may sometimes encounter people using this formula to actually generate that y-coordinate.